inverted pendulum, I just want to see the system, and then by using my hand, that is, if I take it on top at theta, in case of inverted pendulum, that position is called theta equals to 0. Okay, or you can even call theta equals to pi. And then suppose as long as you hold that pendulum at the vertically upright position, it will be there. But the moment you release or you withdraw your arm, immediately it will fall back. That is the nature of the unstable equilibrium point. It can be attained due to some perturbation or any external, when you are doing this, that means you are changing the initial condition. So you are holding at that point means it is theta equals to 0 or pi. It depends upon how you are counting. But theta dot equals to 0 and x dot, of course, they will be 0. So in that condition, what will be your initial condition? 0, 0, pi, 0. Okay. But so that is a non-zero initial condition. But there is no controller. The moment you leave your hand, immediately it will fall. Why? Because that is not a stable equilibrium point. Is it now clear to all of you about the distinction between the stable equilibrium point and what you called unstable equilibrium point? So unstable point, that even if you call it as unstable equilibrium point, but actually you cannot call it as an equilibrium point. Why? Because the definition that we learned, it will violate. Because even for the inverted pendulum, as long as you hold the pendulum at the upright position, it will be there, but the moment you release your hand, it will fall back. Equilibrium point means once the system reaches that point, it should not move away. It should stay there for all future time. But now, if you say that you have an unstable equilibrium point, just you yourself can understand that the definition will be violated.
Sir, to that definition, you should also add the range of perturbation till what it will be applied so that the system stays in that point.
Oh.
When we talk about equilibrium point, once it attains there, it stays there. So we should also add the range of perturbation that we can apply so that the system doesn't move from that position. So it just brings.
No, in the definition of the equilibrium point, that whatever we have learned, that is like x dot equals to 0, that is, or the solution x star, that means it is such a state where the system will be there for all future time. We cannot add anything to that definition. But what you said, that is now in case it depends on the type of the system for which the initial condition,